In this video, we're going to go over slope. And another name for slope is the average rate of change or even the constant rate of change. So slope, average rate of change, and constant rate of change are all meaning the exact same thing. And so what slope is talking about is whenever you have a linear equation or a straight line here, the slope is referring to how quickly this line or slowly this line is increasing or decreasing. So if you think of stairs, sometimes you have very steep stairs, right? That has a very high or quick slope. But if you go up like a ramp, right, for like a wheelchair, it's usually not increasing very quickly. And so you have a slower constant rate of change or average rate of change or slope. So slope has to do with how steep this line is here. And so for slope, we have a couple formulas, and we use the different formulas depending on what information we have. Slope is y2 minus y1 over x2 minus x1. That is your formula for slope when you are given two ordered pairs. If you are going above pre-calculus, which I'm assuming you are since you are in this class, you also need to be familiar with delta y over delta x, which means exactly this. Delta means the change. So this is the change in y, which you find that by subtracting your y coordinates, over the change in x, which you again find by subtracting your x coordinates. And then another one we need to know is rise over run. And we will use this when we have a graph or when we are graphing. And so you can see here by my diagram here, if you're using rise, that is exactly your change in y, which is y2 minus y1 over the rise or over the run, which is x2 minus x1, that's your change in x. So we have three different types of slope that we need to talk about. And I kind of made my formula a little bit too big here, but that's okay. We have three different types of slope. So the first one here is when this is going up from left to right, we call this an increasing slope. And when it is increasing, your slope will always be positive. Okay, so if it is going up from left to right, just like you read, it is increasing. So then the opposite can be said. If it is going down when you go left to right, this is a decreasing slope, and this will always be negative. And then the last one we'll go over is if your line is horizontal, it is not increasing, it is not decreasing, but it is just straight. We call this a constant slope. And when you have this, your slope will be 0. You do also have a line that could be vertical, but because we're talking about functions, vertical lines are not functions. And so we will not include those in this one. So we have increasing from up, going left to right, decreasing going down from left to right, and it's constant if it is a horizontal line. So let's use this information. In example 1, it says find the slope or average rate of change, then determine whether the linear function is increasing, decreasing, or constant. We have 3 examples. On this first one here, we have a picture of a line. Now, I could use this formula here if I wanted to figure out where 2 ordered pairs are, which we're going to need anyway, so let's find that. Looks like I have a point right here at 6, 1. And I have a point right here at 3, 3. And looks like one right here at 0, 5. So we could take any of these 3 points and we could use this formula here, but because it's already on a graph, let's count our rise and let's count our run. So if I go from the bottom point to the middle point, I am rising 2 and I'm going up, so it is a positive 2. And then my run right here is 1, 2, 3, and because it's going in the negative direction, my run is a negative 3. So therefore, my slope, if I'm using my formula of rise over run, is 2 over negative 3. Now I can look at this graph and already see that this graph is decreasing, but I can also tell by looking at this slope that it is negative. And it does not matter which points you pick. I could have went from the middle to the top. We still would have rised 2 and ran a negative 3. Or if I go from bottom to the top, we would rise 4 and then run a negative 6, which reduces to 2 over negative 3. Now on B, I don't have the option here. On B, I'm not given a visual, so we're going to use our formula here. And so I'm going to go ahead and just rewrite it down here. We have y2 minus y1 over x2 minus x1. What I like to do from there is label my points, and then it's just straight substitution. So this is x1, y1, x2, y2. It does not matter what you call your first point and your second point, but you always need x first, then y, and you need your 1s together and you need your 2s together. So I could not call this x1, y2. Okay, you can't, it's got to be 1s together, 2s together, and this is not x1, x2, because this is always in the form of x comma y. So x1, y1, x2, y2. And now just substitute in. So what did we label as my y2? Well, that's 3. Minus from my formula. And then what is my y1? My y1 is a negative 2. Okay, so I have 2 negatives there. The first negative is from my formula. The second negative is from my coordinate. Over x2, which is 5, minus from the formula, and then x1 is a negative 1. So again, 2 negatives, 1 from the formula, 1 from the number. So now let's simplify this. 3 minus a negative 2 is the same as 3 plus 2. 5 minus a negative 1 is the same as 5 plus 1. And so therefore, my slope is 5 over 6. I do not have a visual, but I know because this is positive, that this must be an increasing slope. And then lastly on C, I'm actually going to use my third formula of delta y over delta x. Because I'm given a table, I can determine what my change in y is and what my change in x is. When I look at my y's, how am I going from one point to the next? Well, 4 to 1, we are subtracting by 3. 1 to -2, we're subtracting by 3. -2 to -5, subtracting by 3. And -5 to -8, subtracting by 3. This is why slope is also called the constant rate of change, because it is constant in how it is changing. So here, my delta y is -3. So let's see what delta x is. How are we changing from -2 to -1? Well, here I'm adding 1. What about -1 to 0? Adding 1. 0 to 1, adding 1. And 1 to 2, adding 1. So my delta x is 1. So therefore, my slope is either -3/1, that's fine, or more simplified, -3. Because this is negative, this is decreasing. Make sure you understand these 3 problems before you move on, because we're going to need this for the rest of the lesson.